The distributive property, part 3. More distributive. We're going to practice writing equivalent expressions by using the distributive property. Today's I can use the distributive property to write equivalent expressions with variables. So make sure you have today's date, your I can, and you are ready to go on. Let's look at the shaded region. So here we have a rectangle with dimensions of 6 centimeters, and we have 4 centimeters here. We know that the shaded area has a certain area as well. It's cut into 2 smaller parts. Which of these can we use to, these expressions are used for area for that smaller part? How are both of these possible? Well, think back to what we did in the last lesson. All we're saying here for this entire area is it's 6W, right? If we looked at the entire space. And then if we look at the smaller space, it's 6 times the 4, which is 24. We can think of it as the entire thing together. And to find out this area, we know that this length is W, but if we subtract 4 from W, then we'd have the length that goes in for the shaded area. So we can think of this as 6 times the W minus the 4. So both of these still are going to give us correct. This is just taking that 6 and multiplying it by the parts. This is thinking about solving in here first and then multiplying by the 6. Either way, it's still correct because we've used that 6 and spread it out amongst the parts. So all we've done is just gone and multiplied 6 times the W and then the 6 times the 4 and still subtracted. All right, let's match some distributive properties here. So if we take a look at this one in column 1, we're going to look and match each of these across here. Which one of these would be the same as A? We've got A times 1 plus 2 plus 3. Yeah, it would match here with number 5, right? Because we've taken A times 1, A times 2, and A times the 3, and it's still adding. What about here? 2 times 12 minus 4. Yeah, this one's saying the same thing, right? We've got the 2 times the 12, and then we've got the 2 times the 4. What about the 12A plus 3B? Yeah, that one actually matches right here, doesn't it? Because if you take and divide both of those by 3, you still have the 3 here, but now we've got 4A, which 12A divided by 3 would give you 4A. And then 3B divided by 3 would give you just B, but you still have to have that 3 to finish out at the end. What about this 2/3 times 15A minus B? Yeah, this one gets a little trickier. You have to kind of think about what the numbers would make. So if you take 2/3 times 15, that'd give you 30/3 or 10, right? Same thing with 18. 18 times 2/3 is going to give you what? 36/3, which is 12. So it's this one right here. What about 6A plus 10B? Yeah, that's going to go straight over here, right? Because both of those we can divide out of 2, put that 2 at the beginning. Or you could think of it in reverse, that you take the 2 times the 3A, making 6, and the 2 times the 5B, making 10B. What about 4/10 times 5 minus 2 and 5/10 A? Well, this one's a little bit of a thinker. You've got 4/10 times 5, that gives you 20/10, which is 2, right? 2 and 5/10 though times 4/10. Well, 25 times 4 is 100, but now we have tenths times tenths, so we have to have hundredths. So actually, that 100 is 100 hundredths. So it matches up here. And obviously this last one matches up here because then we're just factoring out the A. Okay? So really when we're talking about, when I say something like factoring out, that just means that I'm dividing out the piece that was used to multiply with the parts. So like here, it's that 3, because originally it was 12a plus the 3b. Here, it was originally 6a plus 10b, but I've got a 2 that's a factor in both those parts. Here, it's the A is the factor in both those parts. You know, it's just lots of ways to look at it. All right, let's write a few equivalent expressions. So what if I take the 3 times 3 plus x? Yeah, I could think of it as 9 plus 3x, right? Because if I take that 3 multiplied by the parts. What about rewriting this one? Yeah, 4 is the common factor in both of those. And we're going to have x minus 5. We're not going to go through every single one of these, but we are going to do a good chunk of them. What about here? 4x plus 7x. Yeah, x is the factor there, right? The x factor. Okay, it sounded way cooler in my head when I said it. Don't boo so much. Thanks. Anyway, so yeah, x is the thing that's multiplied by both parts. We can take that out. What about here? Yeah, this is going to be 6x plus the 3. Notice that in every time, when we're going from the product to the sum or difference that we're making from it, all we're doing is taking whatever's on the outside and multiplying it by each of those parts, keeping whatever operation here still going through. What about here? 1/2 times x minus 6. Yeah, we got 1/2 x, or yeah, 1/2 x. You could have x halves, right? Because 1/2 times x is going to be x over 1/2, right? 3, right? Because 6 times 1/2 is 6 halves, or 3. Ooh, this one looks great. What about this one? We got y times 3x plus 4z. Yeah, now we're getting some complicated stuff. Now we got 3xy plus 4zy. What about this one? What's the common thing here? Yeah, it's that z, isn't it? We got a z in every part of it. So we're going to start off with z. If I divide out the z, I've got 2xy minus 3y plus 4x. I could even break that down further, couldn't I? Yeah, if I really wanted to get crazy, I could go with z. And now I've got parts here that I could take the y out, couldn't I? So then I could have in parentheses y times 2x minus 3 plus 4x. Or I could have taken the x out and you would have had something like you'd had to shuffle around a little bit. You'd had to move the minus 3 apart. But I mean, as far as keeping it in the order that they have here, y is the easiest part. And you could do the x, but it gets a little complex on the explanation. We're not quite to that complexity yet. But I think we are pretty much done. You know, the big thing with each of these is paying attention to those parts. When you're thinking about equivalent expressions, thinking about how you can distribute those multiplication pieces throughout. you know, just real fast, if I had something like 7t plus 14 minus, let's say 28, what's going to be the common factor with all these? Yeah, 7's the common factor, right? So I'd have 7t plus 2 minus 4. And yeah, I could put those together and to have it just as minus 2 here. This is just an example. It's really about looking at what is the factor that can go into all of them. And in this case, it's that 7 goes into every one of those and taking it out beforehand. And the variable can be the factor that we take out as well. So, all right. Thanks for watching.